Okay, so look at the first one. And what we're going to do is take one of the colors and we are going to put a dotted line where the midline is. So this graph goes from -1 to -7. That's a distance of 6 total. So if that's a distance of 6 total, then what's the amplitude? 3. Okay, so that means my midline is going to be 3 away. Okay, so there's my midline. Now, based on the way this graph looks, would it be easier to write a sine equation or a cosine equation? Sine. Okay, so I'm going to start off by writing a sine equation. All right. So my first equation is going to be y equals, what should I put first? 3, yep, amplitude of 3 sine. And then I got to figure out what the period of the graph is. Can you guys tell from the picture? It's 2 boxes for a period. And what's 3 boxes? 3 boxes is pi, so 2 boxes is 2 pi thirds. So 2 pi thirds equals 2 pi divided by b. And so what does b equal? Yeah. So if I look, let me erase this. Okay. So when I looked at this, I could see that pi was right here at the 3rd box. So if pi is the 3rd box, that means this box is 1 pi thirds, 2 pi thirds, 3 pi thirds. So 3 boxes. The period of the graph only took up 2 boxes. So that tells me that the whole period must be 2 pi thirds. So then to figure out what the b value is, I'm going to say 2 pi divided by b equals the period of the graph that we got, which is 2 pi thirds. And so what's the b value? 3. Perfect. Okay. So I have 3 for my amplitude. It's a sine graph. And then what am I going to put in the parentheses? 3x. And what do I put on the end? Be careful. It is the midline. -4 because that's a -4 for the midline. Okay. So that's our sine equation. Now, for the cos equation, we have 2 options. We could think of it going, well, we have more than 2 options. We have a lot of options. We could think of it as being this part to this part right here. So that would be a positive cos graph. We could think of it as this part to this part. That's a negative cos graph. We could think of it as this part to this part. We could think of it as that part to that part. You guys see that? So we have lots of different parts we can think of. Each of those different parts is going to have a different equation to write for it. My recommendation to make your life easier is to pick one that only goes to the left or right a little bit. Yes, you could write this cosine equation over here, but it's going to be harder to write because you're going to have to figure out what number that is, that it went to the left. Okay? So I would recommend doing this one right here, or doing this one right here. That would be my recommendation because that's easier. Do you guys want to do the positive version or the negative version? Negative version? Okay, so what I'm going to do is I'm going to take my other color and I'm going to trace the cos graph so I can see it. Okay? Now, some of the things are going to be the same about the cos graph. The cos graph is going to have the same period, so it's going to have the same b value. The cos graph is going to have the same amplitude. The cos graph is going to have the same midline. The only thing that's going to change about the cos graph is that now it has shifted to the right or to the left, okay? And we have to figure out how much it shifted. So when I go ahead and write this, I'm still going to start off saying y equals, and then I got to decide if my 3 is positive or negative, depending on the picture. So what do I see about my 3 for the cos graph? Negative, it's upside down. So -3 cos. I'm still going to have a 3 in front of my x, because the period of the graph has to stay the same, but I'm going to leave some room so I can put if I went to the left or to the right. And then I'm still going to put the -4 on the end. So most of the equation stays the same. There's just a little bit of a difference. And now I have to figure out how much it went to the left. Can you guys tell? pi6. So it went half of a box. And if a full box is pi3, then half of a box would be pi6. So it went left pi6. So what do I write in here? Plus pi6. Okay, and there's two different equations for the same graph. Are those the only two equations I could have written? No, I could have written a lot, but those are two and they're correct. Okay. Whew. All right, I'm going to show you guys how to graph these types of equations in your calculator so that you can actually see what you're graphing, okay? What I do with a problem like this is I try to set my window to be the same as what I can see the graph representing, okay? So for this one, I'm going to go ahead and hit y equals. And you can type in either one of your equations. They should be the same thing. So let's go ahead and type both of them and just make sure that they graph on top of each other because they're the same equation. So I'm going to say y equals 3 sine of 3x minus 4. And then I'm also going to type in -3 cos 3 parentheses x plus pi over 6 end parentheses minus 4. So I went ahead and I typed both of them in. And then for my window, I want to set my window to be exactly the same as this picture, okay? So I want my window to go from -pi to +pi, okay? So for my x min, I'm going to type -pi. For my x max, I'm going to type +pi. You guys see that? -pi to +pi. The x scale is what the x boxes go by. So how much is one box? pi3. So for x scale, I'm going to type pi divided by 3, pi3. What is the lowest y value we can see? -7. What is the highest y value we can see? 1. And what does the y's go by? 1. So we can leave the y scale as 1. So what I did is I just set up my window to match this picture, okay? And then if I graph it, if I wrote the equations correctly, then these should graph at the same, they should look the same when they graph. So I can see it's still graphing because my calculator's still thinking up here in the right corner. But the reason I didn't see two different graphs is because they graphed on top of each other, which is good. That means my equations give me the same graph, which means I came up with two different equations for the exact same thing. Does this graph match what we have here? Yeah, it does. Oh, the window again? So I did -pi, +pi, this is pi3, and then I did -7 and 1. You are in degrees, probably. So if something funky happens, double check to make sure you're in radians when you graph these, okay? All right, let's try another one. So I might give you one where it's like a multiple choice, and I write down like a couple equations. You have to choose the one that would work for the picture, something like that. Or maybe a matching where I have like 3 different pictures, 3 different equations, and you match them up or something. Okay, so if you look at this one, what's the midline for this one? 2. What type of equation would be easiest to graph? Cos? Cody, would you get the door for me? All right, what's the period for this graph? Anyone know what the period of this graph is? Yeah, it's 2 pi thirds again, and we can tell because 3 boxes is for pi, and we only have 2 boxes out of 3, so our period would be 2 pi thirds. Okay, so we're writing a cos graph first. How do I start my cos graph? Negative, because it's upside down. And then what number? What's the amplitude? 2, negative 2. Cos. All right, and we said that the way that we calculate the b value is we say 2 pi over b, and the period of this graph is 2 pi over 3, so b must equal 3. So inside the parentheses we have 3x again. I don't know why I didn't use all that space, okay? And then what number should we have on the end? Plus 2. Okay. Now for our sine graph, we have lots of options. The easiest options would be to look at this one right here. So there's a negative sine graph. Or we could look at this one right here. That's a positive sine graph. So do you guys want to look at the one that shifted left to make a negative sine graph? Or do you want to look at the one that shifted right to make a positive sine graph? Shifted right? Okay. So I'm going to trace this one now. So how do I start writing this equation? It's a positive sine graph. So it gets a 2 and a sine. And we know some stuff stays the same, right? So I'm going to keep the 3. I know that this graph has shifted to the right, so I'm going to leave some space to write that down. And then I know that the midline is still 2. Okay, and I know I need an x right there. So how much did it shift to the right? Pi 6 went to the right half of a box, which would be pi 6. So we're going to say minus pi over 6. Okay, so let's go ahead and graph this one as well and see what our window should be so that we can see everything. So I'm going to clear my equations. And since the period of the graph, some of the stuff that we typed in last time can stay in the window. Like what parts of the window are we going to want to stay the same? What's the same about the two pictures? Yeah, the x's, they both go from negative pi to positive pi. And they both go by 3 boxes. So we can still say our y min is negative pi and our y max is positive pi, and we can still say that the x scale is pi divided by 3. So that's still going to work to show the picture exactly the way we want it. But the y min and max look different for this grid. So what should our y min be? We could do -1 or -2 because it's kind of in between boxes. Which one do you guys want to do? -2? So we'll do -2. And then how high does the graph go? 4. And does it still go by 1s? Yes. Okay, so let's go ahead and graph it. Does it fit? And mine's still thinking it's graphing the second equation right now, and I just can't see it because we wrote it correctly. So it's graphing on top of the first one. Okay, and that matches the picture, so that means we got it right. Okay, let's look at one more just because what would make number 3 hard to do? they cut off part of the graph. So we can't even see one full cycle. Does that make sense? We can't even see the whole thing. Okay, but we can kind of see the midline because I can see that this graph goes between -2 and +8. So how many numbers are between a -2 and a +8? That's 10 numbers, okay? So we're going to go up 5 and down 5, and that's where the midline is. So the midline is right at 3. So let's go ahead and mark that. It's right at 3. And what we can do is we can look at these markings and see if we can figure out where the graph would have connected to finish the drawing, okay? So this is pi halves, this is pi, this is 3 pi halves. What would have come after that? What comes after that? Pi halves, pi, 3 pi halves, 2 pi would be next. How much is this? Is that the whole period? No. How much is that? That's half of it, okay? So we'll think about this side coming down. So this is negative pi halves, negative pi, negative 3 pi halves. That would be at negative 2 pi. So what does it look like to you the period of the graph is? It looks like 4 pi, okay? All right, so let's figure out the b value. I'm going to go ahead and say 2 pi divided by b equals 4 pi. And how do I solve for b? Yeah, how do I solve for b? Multiply b on both sides, so I'm going to get 2 pi on the left side equals 4 pi times b. Divide by 4 pi, and 2 pi divided by 4 pi is 1/2. So 1/2 equals b. Okay, so the reason that we typically traced the whole graph was so that we could figure out what the period is, and we just did that without tracing anything. Okay, so we know the period of the graph has to be 4 pi, and that means we have a 1/2 that goes in front of our x. So now when we trace part of the graph, all we have to figure out is how to write the equation, okay? So if I start off tracing this, what type of graph would this be? It's in the middle. So that's a sine graph. Okay, so I'm going to say y equals, is that a positive sign or a negative sign? It would go down, it would come up, and then it would come back like this. That's a negative sine graph, right? So I'm going to say negative, what's the amplitude? 5, negative 5 sine. What goes in the parentheses? (1/2). And then what's our midline? 3. So plus 3. Okay. So I can't see the whole graph, but I know that it started in the middle, and that's what told me it was sine. So on the y-axis, it started in the middle. That's what made it sine, and it was going down. Okay? All right.